The first human on the moon expected dust and rock, but found a reality far stranger. That single moment of awe reveals our true relationship with the cosmos. The universe is not a quiet stage. It is a dynamic and bizarre performer, constantly challenging every explorer who dares to look. This journey uncovers 45 times it left scientists speechless, from ghostly forces nudging our spacecraft to stars that vanish without a trace. By the end, your understanding of reality and our tiny place within it will be fundamentally rewritten. What happens when a planet orbits backwards, or a galaxy is missing its most vital component? How much of the cosmos remains hidden from our most powerful tools? Are you ready to see how small our knowledge truly is? The universe began its quiet tests almost immediately. Our first deep space messengers, the Pioneer 10 and 11 probes, were speeding towards the outer planets when a ghostly finger seemed to tap them back. Tracking data revealed an inexplicable truth. They were slowing down. It was a minuscule deceleration, a force 10 billion times weaker than gravity's pull at Earth's surface, but it was undeniably there. This tiny, persistent deviation, this whisper from the void, became known as the Pioneer Anomaly. For over 2 decades, it haunted the halls of theoretical physics. Was Newton's law of gravity incomplete at the vast scales of the solar system? Were we seeing the first hints of dark matter's subtle influence, or perhaps an entirely new cosmic force? The mystery consumed experts like Slava Torishev, who led a painstaking effort to recover and analyze decades of old data, tapes, and telemetry. The answer, when it finally came, was not written in the stars but in the gentle, uneven warmth of the spacecraft themselves. The culprit was a faint, lopsided push from thermal radiation. The plutonium in their power generators produced heat, which the probes radiated away into space. Just a little more of this heat escaped from the back of the craft than the front, creating a tiny, constant thrust that acted as a perpetual brake. It was a phantom born from our own engineering. This solution, so mundane and yet so elusive, delivered a profound lesson. The cosmos challenges us not only with its grand explosions and missing galaxies, but with the quietest, most subtle details we overlook. It reminds us that our own creations can become the source of the deepest mysteries. And if a faint whisper of heat could confound us for 20 years, what chaos would a cosmic scream unleash? While the Pioneer probes carried a phantom in their own warmth, the cosmos would soon send a message that felt anything but internal. Decades of radio silence were broken by a single, shocking event. At the Big Ear Radio Telescope in Ohio, data streamed onto a continuous printout every night, a river of cosmic noise. One evening in 1977, an astronomer named Jerry Amon was performing a routine check of the previous night's data. His eye caught a string of letters and numbers, 6EQUJ5, a sequence that represented a signal spike of immense power. It was so perfectly aligned with what scientists predicted an artificial, interstellar transmission would look like that Amon, stunned, circled the code and wrote one word in the red pen's margin. Wow! This was the wow signal, a 72-second burst of radio waves that came from the direction of the constellation Sagittarius. It swept across the telescope's receiver as the Earth turned, hitting the precise frequency that hydrogen, the most common element in the universe, emits quietly in the void. For 1 minute and 12 seconds, it screamed into the silence, and then it was gone. Not a trace, not a repeat. Not even a faint echo in the decades of searching that followed. That singular, fleeting event became a ghost in the machine of astronomy. Was it a cosmic flare of a type we have never seen before, or the first and only brush with a civilization announcing its presence? The signal's perfect profile and its mysterious, one-off nature make it a monument to our loneliness and our hope. It is a haunting reminder that the universe might be shouting, but our ears are only open for the briefest of moments. This makes the sudden, tangible evidence of a rock from Mars landing on our own world feel like a solid handshake after a distant, fading whisper. A whisper from the stars is one thing, but a rock that hands you a possible fossil is another. In the vast, silent plains of Antarctica, a dark lump of stone sat waiting in the ice. Designated ALH8 4001, this was no ordinary rock. Its chemical signature was a perfect match for the Martian soil analyzed by the Viking landers. It was a piece of Mars, blasted from its home world by a colossal impact, and sent on a multimillion-year journey to fall gently onto Earth. When scientists carefully opened it in 1996, they were met with a sight that stopped the world. Inside were structures that looked uncannily like the fossilized remains of ancient bacteria, tiny worm-like forms and distinctive carbonate globules that on Earth are often created by biological processes. The NASA team, led by David McKay, made an announcement that ricocheted around the globe. They presented not just a theory, but an artifact. We might be holding the first physical evidence of life beyond our planet. The public imagination ignited. The debate within science, however, was fierce and immediate. Other researchers argued that every single feature could be explained by non-biological processes. The worm-like shapes could be mineral formations. The carbonate globules could have been forged in the intense heat of the impact that launched the rock into space. For decades, the evidence has been picked apart and re-examined, with the consensus leaning away from a biological origin. Yet the initial shock of that discovery never truly faded. It fundamentally shifted the entire pursuit of astrobiology from a speculative field to a concrete one. It taught us that the most profound answers might not come from a distant signal, but from a physical sample, a piece of another world that has been delivered to our doorstep. The universe was no longer just a place we looked at. It was a place we could hold in our hands. If a rock could challenge our understanding of life itself, then what about a fundamental force that seemed to be changing right before our eyes? Gravity should have been pulling the universe back together. Every scientist watching the cosmos in the 1990s knew this fundamental truth. The great cosmic expansion that began with the Big Bang had to be slowing, its galaxies gradually succumbing to the collective pull of all the matter they contained. It was the only logical outcome. Two rival teams, one led by Saul Perlmutter and another by Brian Schmidt and Adam Rees, set out to measure this deceleration by studying distant stellar explosions called Type 1, a supernova. These cosmic beacons are so consistent in their brightness that they act as perfect mile markers, allowing for a precise measurement of how fast the universe was expanding in the past. The data came in, and it pointed to a conclusion so bizarre that the researchers assumed they had made a catastrophic error. The universe was not slowing down at all. It was speeding up. The expansion rate was accelerating. It was as if you tossed a ball into the air and instead of falling back, it shot away from you faster and faster, forever. The universe, against all reason and expectation, was blowing itself apart. This discovery, which earned a Nobel Prize, demanded a terrifying explanation. Something was overpowering the collective gravity of every galaxy, star, and planet. That something was given a name, dark energy, a mysterious repulsive force woven into the fabric of space itself. We cannot see it, touch it, or detect it directly, yet calculations show it makes up about 68% of the entire cosmos. It is the dominant component of reality, and we have almost no idea what it is. This single finding rewrote the ultimate fate of everything. Instead of a potential future collapse, the cosmos is now headed for a cold, lonely, and ever-accelerating expansion, where distant galaxies will eventually fade from view entirely. The force that governs the large-scale destiny of the universe is a total mystery, a phantom pressure in the vacuum of space. If the fate of the whole cosmos is dictated by the invisible, then perhaps it is no surprise that individual stars can hold secrets just as profound, secrets that begin with a simple, rhythmic flicker in the night. Mars stopped in the night sky. To the ancient astronomers who tracked the heavens with unwavering dedication, this was a profound and unsettling event. The steady, forward march of the red planet would halt. Then the world would reverse its course, tracing a glowing, looping arc against the backdrop of fixed stars for weeks on end before finally resuming its original path. This was retrograde motion, a celestial dance that shattered the elegant idea of a universe revolving perfectly around the Earth. How could a planet, believed to be embedded in a perfect crystalline sphere, simply decide to wander backwards? This single, stubborn surprise defied every geocentric model, creating a crack in the foundation of cosmic understanding that would eventually bring the entire structure down. It was this very puzzle that consumed the mind of Nicolaus Copernicus, who realized the cosmos made far more sense if the Sun, not the Earth, was placed at the center. Later, Johannes Kepler, using the precise observations of Tycho Brahe, discovered the true reason for the loop. It was an illusion of perspective, a cosmic overtaking. Imagine two runners on concentric tracks, with Earth on the inner, faster lane. As we lap the slower-moving Mars, our changing viewpoint makes the distant planet appear to slide backwards against the far more distant stars. This apparent defiance was not a flaw in the planets, but a flaw in our perception. That simple correction, born from a celestial surprise, rewrote our place in the universe. We were no longer the motionless center of creation, but a world orbiting a star among many. The strange wobble of a distant exoplanet today presents a modern echo of that ancient puzzle, a new loop in the sky begging for an explanation. The orderly dance of the planets, explained so perfectly by Newton, held a tiny, persistent flaw. Mercury, the Sun's swiftest and innermost child, was wobbling. Its entire elliptical orbit was slowly pivoting around the star, a phenomenon called precession. While most of this shift could be explained by the gravitational tugs from the other planets, a small fraction remained stubbornly unaccounted for. Every century, the point of Mercury's closest approach to the Sun, its perihelion, advanced by just 43 arcseconds more than Newton's equations predicted. This was a minuscule amount, a deviation equivalent to the width of a human hair seen from a mile away, but for physicists, it was a screaming anomaly. It was a ghost in the machine of the solar system, a clear sign that something was missing from our understanding of gravity itself. For decades, this tiny mismatch was a nagging puzzle, a crack in the foundation of classical physics. Then came a young patent clerk with a radical new vision of the cosmos. Albert Einstein's theory of general relativity proposed that gravity is not a mysterious force acting across distance, but the result of mass warping the very fabric of space and time. The Sun, in this new picture, sits like a heavy bowling ball on a stretched rubber sheet, creating a deep depression in space-time. Mercury, orbiting so close, travels through this profoundly curved region. Its path is not a perfect static ellipse, but a rosette pattern that slowly rotates over time. When Einstein applied his complex field equations to Mercury's orbit, the result was a moment of pure triumph. The math spat out the exact number that had baffled astronomers for generations: 43 arcseconds per century. The ghost was gone, explained by the curvature of the universe itself. This was not just a correction, it was a revolution. The successful explanation of Mercury's precession was the first major validation of general relativity, proving that our universe operates not on a flat, predictable grid, but on a dynamic, malleable fabric. The subtle, relentless wobble of a single planet confirmed that space and time are intertwined and flexible, a stage that is constantly bending and shifting under the weight of its actors. If the gentle gravity of our Sun can warp the paths of worlds, then what chaotic distortions must be generated by the most violent objects in the cosmos, where space-time is not merely curved, but torn? That rhythmic pulse from deep space was a metronome of cosmic order, a beacon of such perfect timing it seemed artificial. But the universe rarely stays orderly for long. Just a few years after the discovery of pulsars, a far more violent signal ripped through our solar system. It was 1969, and the American Vela satellites, designed to monitor for clandestine nuclear weapons tests, registered something impossible. A flash of gamma rays, the most energetic form of light, had arrived from somewhere beyond the Earth, and it had come from deep space. This was not a steady, ticking pulse. It was a sudden, colossal burst of raw power, appearing from nowhere and vanishing just as quickly. For years, the data was treated as a top-secret military anomaly. The source was a complete enigma. Were these explosions happening in our own solar system, perhaps from asteroids colliding in the distant Oumuamua cloud? Or were they coming from the edges of the Milky Way, involving unimaginable energies? The debate raged for decades with no clear answer. The breakthrough came with the launch of NAS, a Compton Gamma-ray observatory in the 1990s. Its sophisticated instruments mapped the bursts across the entire sky, and the result was stunning. The gamma-ray bursts were not clustered along the plane of our galaxy. They were distributed perfectly evenly in all directions. This could only mean one thing: the sources were not local. They were not even from our galactic neighborhood. They were coming from incredibly distant galaxies, billions of light years away. For a burst of light to be visible from such a staggering distance, the explosion that created it had to be the single most energetic event in the universe since the Big Bang itself. In a fraction of a second, a single gamma-ray burst can release more energy than our Sun will emit over its entire 10 billion-year lifetime. We now know these cosmic detonations are the birth cries of black holes, unleashed during the hypernova death of a massive, rapidly spinning star or the cataclysmic merger of two neutron stars. The universe had revealed a new breed of monster, a transient, universe-spanning flash that could, for a fleeting moment, outshine every other star in the cosmos combined. The discovery proved that the calm night sky is a grand illusion, a placid surface hiding energies so vast they defy human comprehension. If the universe can casually unleash such power from a dying star, what other invisible forces might be shaping the cosmos on an even grander scale? Forces whose presence we can only feel through their ghostly gravitational pull. That rhythmic pulse from deep space was a metronome of cosmic order, a beacon of such perfect timing it seemed artificial. But the universe rarely stays orderly for long. Just a few years after the discovery of pulsars, a far more violent signal ripped through our solar system. It was 1969, and the American Vela satellites, designed to monitor for clandestine nuclear weapons tests, registered something impossible. A flash of gamma rays, the most energetic form of light, had arrived from somewhere beyond the Earth, and it had come from deep space. This was not a steady, ticking pulse. It was a sudden, colossal burst of raw power, appearing from nowhere and vanishing just as quickly. For years, the data was treated as a top-secret military anomaly. The source was a complete enigma. Were these explosions happening in our own solar system, perhaps from asteroids colliding in the distant Oumuamua cloud? Or were they coming from the edges of the Milky Way, involving unimaginable energies? The debate raged for decades with no clear answer. The breakthrough came with the launch of NAS, a Compton Gamma-ray observatory in the 1990s. Its sophisticated instruments mapped the bursts across the entire sky, and the result was stunning. The gamma-ray bursts were not clustered along the plane of our galaxy. They were distributed perfectly evenly in all directions. This could only mean one thing: the sources were not local. They were not even from our galactic neighborhood. They were coming from incredibly distant galaxies, billions of light years away. For a burst of light to be visible from such a staggering distance, the explosion that created it had to be the single most energetic event in the universe since the Big Bang itself. In a fraction of a second, a single gamma-ray burst can release more energy than our Sun will emit over its entire 10 billion-year lifetime. We now know these cosmic detonations are the birth cries of black holes, unleashed during the hypernova death of a massive, rapidly spinning star or the cataclysmic merger of two neutron stars. The universe had revealed a new breed of monster, a transient universe-spanning flash that could, for a fleeting moment, outshine every other star in the cosmos combined. The discovery proved that the calm night sky is a grand illusion, a placid surface hiding energies so vast they defy human comprehension. If the universe can casually unleash such power from a dying star, what other invisible forces might be shaping the cosmos on an even grander scale? Forces whose presence we can only feel through their ghostly gravitational pull. Every great explosion leaves an echo. For two radio astronomers at Bell Labs, that echo was an infuriating, persistent hiss. Arno Penzias and Robert Wilson were testing a highly sensitive horn antenna in 1964. But their work was plagued by a constant, uniform noise that seemed to come from every direction in the sky. They scrubbed the instrument clean, even evicting a pair of pigeons and their messy nest, convinced the signal was a terrestrial nuisance. Yet the static remained, a whisper that would not be silenced. This was not a flaw in their equipment. It was the faint, cooled remnant of the universe's very first light, the cosmic microwave background radiation. This discovery was the smoking gun for the Big Bang theory. It confirmed that our entire cosmos began in a state of unimaginable heat and density, and what they were hearing was the afterglow of that primeval fireball, now cooled over 13.8 billion years to just a few degrees above absolute zero. This radiation is a snapshot of the infant universe, taken when it was a mere 380,000 years old, the moment it cooled enough for light to finally travel freely. The map of this afterglow, created by satellites like COBE and Planck, revealed another profound shock. The temperature of this ancient light is almost perfectly uniform, with variations of only 1 part in 100,000. This incredible smoothness was a puzzle in itself, one that led directly to the theory of cosmic inflation, a brief period of faster-than-light expansion in the universe's first moments that stretched it into the homogeneous state we see in that baby picture. This faint, cold glow is the oldest fossil we will ever observe, the literal wall of our visible universe. It set the stage for everything that followed, a smooth canvas upon which the first tiny ripples would grow into the vast cosmic web of galaxies we see today. Having mapped the oldest light in creation, astronomers turned their gaze to the structures that grew from its subtle imperfections, only to find a galaxy that seemed to break the most fundamental rules of cosmic architecture. Our own galaxy is not drifting aimlessly through the void. In the 1970s and 80s, astronomers charting the grand motions of the cosmos uncovered a startling truth. The Milky Way, along with our entire local group of galaxies and millions of others, is caught in a vast cosmic current, all flowing toward a specific, invisible point in the distant sky, toward the constellations of Centaurus and Hydra. This mysterious, immense gravitational anchor was named the Great Attractor. It was as if every ship in an ocean was being pulled toward a hidden whirlpool, its core completely obscured from our view. The plane of our own galaxy, a thick band of dust and stars, created a blind spot astronomers call the zone of avoidance, which perfectly concealed the heart of this gravitational mystery. For years, the true nature of the Great Attractor was a profound puzzle. What colossal structure could possibly exert such a pull on millions of galaxies? The answer, revealed by modern infrared and radio surveys that can peer through the galactic dust, was both simpler and more grand than anyone imagined. The Great Attractor is not a single, unimaginably dense object. It is a gigantic supercluster of galaxies, a gravitational nexus so massive that it dictates the motion of our entire galactic neighborhood. We now understand it as the central density peak of the Laniakea supercluster, a vast celestial continent that spans over 500 million light-years, and our Milky Way is merely a suburban town on its outermost fringe. The surprise was the humbling realization of our true place within this cosmic flow. We are not stationary observers, we are passengers on a galactic raft, caught in a gravitational river flowing toward a distant, hidden shore. This discovery of a hidden focal point, its influence felt long before it was seen, perfectly set the stage for the most profound invisible of all, an entity whose presence is known only by its ghostly grip on everything we can see. The universe is a silent, dynamic fabric, and in 2015, we felt it ripple for the very first time. A century after Albert Einstein mathematically predicted their existence, a tiny, almost imperceptible shudder passed through our planet. It was a gravitational wave, a distortion in spacetime itself, generated by a cataclysm that occurred over 1 billion years ago. Two black holes, each roughly 30 times the mass of our Sun, had been locked in a final, fatal dance. Spiraling toward each other at nearly the speed of light, they merged into a single, more massive black hole, and in that violent union, they shook the cosmos. The event released a titanic burst of energy, equivalent to 3 times the mass of the Sun converted directly into gravitational waves, which radiated outward at light speed. By the time this ripple reached Earth, its effect was almost unimaginably small, stretching and squeezing our entire planet by less than the width of a single atomic nucleus. This is the signal that the Laser Interferometer Gravitational Wave Observatory, or LIGO, was built to find. Twin facilities in Louisiana and Washington state, each with laser beams traveling down 4-kilometer-long vacuum tubes, acted as the most sensitive rulers ever conceived. The passing wave minutely altered the length of one arm relative to the other, and the lasers recorded the change. The signal was not a dramatic crash, but a faint, rising chirp, a cosmic birdsong that lasted just 0.2 of a second. When the computer algorithms flagged the event, the researchers were initially in disbelief, but the data was perfect, matching the predictions of Einstein's general relativity with stunning precision. This was not a discovery made by seeing. It was a discovery made by feeling. It confirmed that space-time is indeed a flexible medium, and it opened an entirely new window on the universe, an era of gravitational wave astronomy where we can now hear the invisible. We can listen to the collisions of neutron stars and the silent, rippling aftermath of the most violent events in creation. Having heard the echo of 2 black holes merging, the next logical step was to try and see the unseeable, to capture the shadow of the monster itself. For generations, the black hole was a phantom in the equations of physics, a place where gravity was so absolute that reality itself broke down. Seeing the unseeable was a logical contradiction. How do you take a picture of an object that devours light? The answer arrived in April 2019, a grainy, fiery orange ring that instantly became an icon. The Event Horizon Telescope collaboration had done the impossible, capturing the shadow of the supermassive black hole at the heart of the galaxy Messier 87. This was not a direct image of the black hole, for that is forever hidden. Instead, the picture shows the black hole's silhouette against the incandescent glow of its accretion disk, a maelstrom of superheated gas and dust swirling at nearly the speed of light. The dark central void is the event horizon's shadow, a region where light is bent so severely that it creates a perfect circle of darkness. Achieving this required a telescope with a lens as wide as our planet. By synchronizing the timing of radio observatories from the high deserts of Chile to the volcanoes of Hawaii and the frozen peaks of the South Pole, Scientists created a virtual Earth-sized dish with unprecedented resolving power. The resulting data was so vast it had to be physically shipped on hard drives to central processing centers. This single, blurry image provided the most direct evidence ever for the existence of black holes, and it allowed for a profound test of Einstein's general relativity. The size and shape of that shadow matched the predictions of his century-old theory with stunning accuracy, confirming its power even at the very brink of spacetime. A mathematical ghost was made real, transforming our understanding of the cosmos from mere theory into observable reality. If we can now see the shadow of a gravitational giant, what other strange stellar behaviors might we uncover? Not in the dark heart of a galaxy, but in the flicker of a single, ordinary-looking star. Those brilliant, star-like points of light were cosmic mirages. In the early 1960s, astronomers trained their telescopes on what appeared to be faint, blue stars, but their spectra told a story of pure chaos. The emission lines were wildly shifted toward the red end of the spectrum, a sign of immense velocity and distance. These were not stars in our own galaxy. They were quasi-stellar radio sources, or quasars, and they were fleeing from us at tremendous speeds, placing them billions of light years away. The shocking part was their luminosity. To be visible across such a vast gulf of space, each of these tiny pinpricks had to be brighter than an entire galaxy containing hundreds of billions of stars. Even more bizarrely, their light flickered over periods of days or even hours. This rapid variability revealed the true size of the engine, because an object cannot flicker faster than light can travel across it. The powerhouse at the quasar's heart had to be smaller than our own solar system. How could something so compact outshine the combined light of every star in a galaxy? The only conceivable power source was a supermassive black hole, a monster weighing millions or even billions of times the mass of our Sun. As colossal amounts of gas, dust, and even whole stars spiraled into this gravitational abyss, the material formed a furious, white-hot accretion disk. Friction and tidal forces heated it to millions of degrees, converting matter into radiation with an efficiency far beyond that of nuclear fusion. Quasars were the violent teenage phase of galaxy evolution, a time when the central black hole feasted gluttonously, lighting up the early universe with its cosmic fire. These distant powerhouses showed that black holes are not just passive vacuum cleaners. They can be the brilliant engines that shape their galactic homes. After contemplating these universe-spanning beacons, the idea of finding something as simple and essential as water on our own barren moon feels almost quaint, a quiet surprise waiting in our own celestial backyard. Our own moon has always been a symbol of absolute desolation, a world bleached dry by the sun and scoured by vacuum. The rocks brought back by the Apollo astronauts were parched, seemingly confirming that water could not survive on an airless body. The truth, however, was hiding in the shadows, deep within the polar craters, in places where sunlight has not reached for billions of years. The temperature plunges to a permanent, profound cold. These are the cold traps, and they have been collecting a treasure. Missions like India's Chandrayaan-1 spacecraft and NASA's a deliberate L-cross impactor revealed the definitive, shimmering signature of water ice. This was not a trace amount, but a substantial reservoir, a frozen history book delivered over eons by the impacts of comets and asteroids. The implications of this discovery are staggering. Water is the oil of space exploration. It is not just for drinking. It can be split into breathable oxygen and, crucially, into hydrogen and oxygen for rocket fuel. Suddenly, the moon transformed from a barren rock into a cosmic gas station. It became a potential stepping stone, a base camp where we could refill our tanks for the long journey to Mars and beyond. We found the most vital resource for life and exploration not on a distant, blue world, but in the darkest, coldest corners of our closest neighbor. If water can survive in the sunless vaults of the moon, Then where else in our solar system are these life-sustaining caches waiting to be found? Perhaps in places with far more generous conditions. The thin, cold air of Mars is a ghost of an atmosphere, composed almost entirely of carbon dioxide. Yet drifting through this sparse gas are fleeting, mysterious plumes of methane. This simple molecule, made of 1 carbon and 4 hydrogen atoms, is a profound enigma on a world thought to be geologically and biologically inert. On our own planet, methane is the signature of life. It billows from wetlands, from the digestive tracts of livestock, and leaks from the deep, hot metabolism of subterranean microbes. But it can also be forged in the absence of life, through the slow, chemical dance of water, heat, and specific types of rock. So when the Mars Express orbiter first sniffed it out, and later when the Curiosity rover confirmed its presence right at the surface, a single, electrifying question took hold. Is this a whisper from Martian biology, or just the creaking of a dead world? The mystery only deepens with the gas's bizarre behavior. It does not linger and mix evenly into the atmosphere. Instead, it appears in sudden, localized bursts that then vanish without a trace. The rover has even documented a faint but regular seasonal cycle to the background levels, a pulse that rises and falls with the Martian year. This points to an active, ongoing source, something happening beneath the rusty soil right now. The leading non-biological suspect is a process called serpentinization, where water interacts with the mineral olivine in the presence of heat, releasing methane as a byproduct. This would suggest that Mars possesses hidden aquifers, pockets of liquid water locked deep underground where chemistry, not life, is at work. Yet the tantalizing possibility remains that the source is biological, that simple, resilient microbial communities are thriving in the damp darkness beneath the frozen regolith, their metabolic waste seeping up to the surface. This methane is a riddle wrapped in a plume of gas, a clue that has kept the hunt for Martian life burning brightly. It proves that Mars is not a static museum piece, but a dynamic world with secrets still locked away. While we search for life's faint signature on the planet next door, other discoveries reveal worlds that defy our most basic expectations of what a planet can even be. Our own solar system seemed to be a perfect blueprint. Small, rocky worlds like Mercury and Venus held the inner orbits, while the gas giants, the Jupiters and Saturns, reigned in the deep, cold freeze far from the sun's heat. This orderly arrangement felt like a universal rule, a logical outcome of how planets must form. Then, in 1995, that comforting model was obliterated. Swiss astronomers Michel Mayor and Didier Queloz pointed their telescope at the star 51 Pegasi and found a world that should not exist. It was a gas giant, a behemoth comparable to our own Jupiter, but it was not residing in a distant, stately orbit. This planet, named 51 Pegasi b, was clinging desperately to its star, completing a full orbit in just 4.2 Earth days. The implications were staggering. At that proximity, the planet's surface would be roasted at temperatures over 1,000 degrees Celsius, a searing hellscape that earned this new class of world a fitting name, the Hot Jupiter. Its very existence broke every planetary formation theory we had. A gas giant cannot form that close to a star. The heat and radiation would blow the lightweight gases away before a core could ever accumulate. The only possible explanation was that this planet was born elsewhere, in the cooler outer regions of its system, and then something forced it to spiral inward, migrating over millions of years to its current, scorching address. This discovery, which later earned a Nobel Prize, was a cosmic wake-up call. It proved that our solar system is not the template for the galaxy, but merely one quirky example among countless possibilities. The floodgates were now open, and a torrent of strange new worlds began to pour in, each one more bizarre than the last. If a planet could defy gravity's expectations so dramatically by hugging its star, then what other gravitational acrobatics might be possible? Like a world perpetually balanced between two suns. Science fiction's most iconic sunset became a scientific reality in 2011. The Kepler Space Telescope, staring unblinkingly at a patch of sky, detected a subtle, rhythmic dance of shadows around a pair of stars. The data revealed a Saturn-sized world, Kepler 16b, but its orbit was not around a single star. This planet traced a wide, stable path around both stars, a true circumbinary planet. Its discovery was confirmed by a complex pattern of stellar dimming, a double transit where the planet would sometimes eclipse one star, sometimes the other, and sometimes both in a sequence that could only be explained by this unique gravitational arrangement. The true surprise was not just that it existed, but that it was stable at all. The gravitational tug-of-war between two stars should, in theory, create a chaotic environment where the violent pulls would tear apart any fledgling planet or fling it into the void. Yet Kepler 16b had found a graceful, distant orbit where the combined gravity of the binary pair creates a single, stable center of mass, and the planet loops around that. This proved that planetary formation is an incredibly robust and adaptable process, capable of assembling worlds even in the dynamically complex whirl of a double-star system. It dramatically expanded the potential real estate for planets in our galaxy, as a majority of stars are found in binary or multiple systems. The universe had taken a staple of science fantasy and stamped it with a certificate of authenticity. If a world can find stability in the gravitational whirlwind of two suns, then what of the ultimate cosmic loners? Planets that have been flung from their stellar homes entirely to drift forever in the deep, cold dark between stars. Our own planet is tethered by gravity to a life-giving star. But this is not the fate of every world. Drifting in the absolute cold and dark between stars are the cosmic nomads, the rogue planets. These are entire worlds, some potentially Earth-sized, that have been violently evicted from their home solar systems. During the chaotic gravitational dance of a young planetary system, a close encounter with a gas giant can act like a cosmic slingshot, flinging a smaller world out of its orbit and into the endless void. These planets are the ultimate orphans, untethered from any sun, destined to wander interstellar space forever. Finding them is a monumental challenge, as they emit no light of their own and reflect none. The key to their discovery lies in a phenomenon predicted by Einstein: gravitational microlensing. When one of these dark wanderers passes in front of a distant background star, its gravity acts as a tiny lens, bending and briefly amplifying the star's light. That subtle, temporary brightening is the only signature of the planet's silent passage. Surveys using this technique suggest a staggering truth. These rogue planets may vastly outnumber the stars in our galaxy, meaning there could be billions, even trillions, of these frozen, lonely worlds adrift in the darkness. Their existence paints a picture of planetary formation far more violent and unstable than we once believed. A universe where ejection is a common planetary fate. Contemplating these sunless wanderers adrift in the void naturally draws our gaze to the most famous wanderer in our own solar system, a world whose own chaotic origins were only recently uncovered. The orderly clockwork of our solar system breaks down entirely in the deep freeze, far beyond the last of the giant planets, in a region of perpetual twilight. A lonely world traces a path that defies all logic. This is Sedna, a reddish planetoid discovered in 2003, and its orbit is a cosmic paradox. For 11,400 years, this distant object makes a single, agonizingly slow loop around the Sun. It swings out to an almost unimaginable distance of 937 astronomical units, so far that our Sun would appear as little more than an exceptionally bright star. Yet, at its closest approach, it never comes near enough to be influenced by Neptune or any other giant planet. It is a solitary traveler on a detached, highly elliptical path. a loop that seems completely untethered from the gravitational dance of the known planets. How did it get there? This is the question that haunts planetary scientists. Sedna's orbit is a fossil, a gravitational scar from a violent event in our solar system's infancy. One compelling theory suggests that a passing star in the Sun's early stellar cluster could have gravitationally yanked Sedna into its current lonely state. But the most tantalizing explanation points to a ghost still lurking in the darkness, the hypothetical Planet 9. This would be a super-Earth, a world several times more massive than our own, orbiting far beyond Pluto. Its immense gravity, over billions of years, could have shepherded Sedna and other detached objects into their strange, clustered orbits. Sedna is therefore more than just a frozen rock. It is a celestial clue. It is a surprise that hints at a hidden chapter in our own solar system's history, and possibly at a massive, unseen neighbor still waiting to be found. To have such a profound mystery in our own cosmic backyard is as startling as finding a star that simply refuses to follow the rules of physics itself. Kepler's unblinking eye recorded the steady heartbeat of a distant star, until one star's rhythm broke into chaos. KIC 8462852, known as Tabby's star, did not behave like the hundreds of thousands of others in the telescope's field of view. Its light did not dip in the gentle, predictable way of a planet crossing its face. Instead, it plummeted. The star's brightness would drop by staggering amounts, up to 22%, as if a vast, ragged shape were drifting erratically in front of it. These were not clean, repeating transits. They were deep, irregular, and utterly baffling eclipses. The data defied every conventional explanation. A planet, even a giant one, could never block so much light. A dust cloud from a planetary collision would have slowly dissipated and settled. This was different, a signal of something immense and strangely structured, passing in front of the star in a way that nature had never shown us before. The most captivating, if wild, theory emerged. Could this be evidence of an alien megastructure? A vast swarm of energy-collecting panels arranged in a Dyson sphere under construction. The idea was electrifying, a testament to how thoroughly the data had confounded our understanding. While most astronomers leaned toward more natural, if still exotic, causes like a fragmented comet swarm or a complex disk of fine dust, the definitive answer remains just out of reach. Tabby's star became a modern icon of cosmic mystery, a powerful reminder that our galaxy holds phenomena we have not even begun to categorize. It also showcased a new era of discovery, where dedicated citizen scientists could sift through public data and help professionals flag the universe's weirdest outliers. This single, flickering star proved that the greatest surprises are not always found in what we see, but in what we cannot explain. And if the behavior of one star can so thoroughly defy expectation, what does it mean when we find an entire galaxy that appears to be missing the one thing that holds every other galaxy together? A galaxy can be a ghost, heavy with mass yet barely whispering in light. In the dense Coma cluster, a cosmic city of galaxies, astronomers found such a phantom, Dragonfly 44. It was as massive as our own Milky Way, a colossal structure that should have blazed with the light of hundreds of billions of stars, but it did not. This galaxy emitted a mere 1% of the light it should have. Its stars scattered so thinly that it was nearly transparent, a wisp of cosmic smoke. Dragonfly 44 is an ultra-diffuse galaxy, a class of object that redefines our idea of what a galaxy even is. Its visible stars are not the main event. They are just accidental tracers, a faint glitter thrown across the surface of an immense, invisible ocean of dark matter. The staggering conclusion is that this galaxy is almost entirely made of the stuff we cannot see. The normal matter, the stars and gas we think of as a galaxy, is just a minor contaminant in a vast, massive halo of dark matter. Its existence is a profound shock to our models of galaxy formation. How could so much dark matter clump together to create a gravitational scaffold this strong, while attracting so little of the ordinary raw material needed to birth stars? It suggests that dark matter can form its own architectures, its own invisible cities, completely independent of the luminous universe we perceive. This ghostly galaxy is a cosmic paradox, a place where the map of gravity and the map of light show two entirely different worlds. If a galaxy can be so dominated by the invisible, then what do we make of the ultimate opposite? A galaxy that appears to have no dark matter at all. A galaxy without its ghost is a cosmic paradox. If Dragonfly 44 is an invisible giant cloaked in dark matter, then its counterpart, NGC 1052 DF2, is a phantom of a different kind. This ultra-diffuse galaxy appears to have no dark matter at all. The discovery came from measuring the speeds of its bright globular clusters, the dense balls of ancient stars that orbit the galaxy's core. Their motion told a shocking story. They were moving with a leisurely, almost sluggish pace, indicating that the gravitational pull holding the galaxy together was coming only from the visible stars themselves. There was no extra mass, no hidden anchor of dark matter to explain their orbits. This finding was as disorienting as finding a massive, intricate building standing firm without any foundation. For decades, the prevailing model of cosmology held that dark matter is the essential skeleton of every galaxy. The normal matter, the stars and gas we see, simply falls into and condenses within these vast, invisible gravitational wells. NGC 1052 DF2 shatters that elegant picture. It proves that dark matter and normal matter can, under the right circumstances, be pulled apart. One theory suggests this galaxy might be a tidal dwarf, a splash of stars and gas that was flung out during a violent galactic collision, a fragment born from normal matter alone, leaving its dark matter parent behind. Its very existence is a powerful, if perplexing, confirmation that dark matter is a real, physical substance that can be separated from stars, and not just a misunderstanding of how gravity works. This galaxy is a unique laboratory, a control experiment for the entire universe, showing us what happens when a galaxy tries to form without its dark scaffolding. It forces us to ask how such a fragile structure could ever come together and survive. The universe has presented us with two impossible extremes: a galaxy made of almost nothing but dark matter, and a galaxy with none. Both are real and both are true. This leaves us with a humbling thought. Our fundamental rules for how the cosmos assembles itself are still being written. If a galaxy can lack its most vital component, then what other cosmic certainties are merely illusions, waiting to be broken by the next surprise? A star simply blinked out of existence. In the 1950s, a brilliant star, 25 times more massive than our Sun, was clearly captured on photographic plates in the dwarf galaxy Kinman. It was a luminous blue variable, a massive, unstable star prone to giant outbursts. For decades, astronomers studied its distinct signature. Then, when the powerful Very Large Telescope turned its gaze to the same spot in the 2010s, the star was gone. There was no trace, no expanding cloud of debris, no fading afterglow from a supernova. It had not exploded, it had simply vanished from the sky. The leading explanation is as startling as the disappearance itself: a failed supernova. This is the theoretical fate of a star so massive that its own core collapse is too efficient for a rebound shockwave to form. Instead of blasting its outer layers into space in a final, defiant blaze, the entire star simply implodes, collapsing directly into a black hole. The star falls into its own grave, pulling the cosmic curtains shut behind it without a sound. This silent exit challenges everything we thought we knew about the death cries of massive stars. It suggests that a significant population of black holes could be forming in the darkness. their births completely unnoticed. This quiet death stands in stark contrast to a very different and very loud stellar demise, one that did not just leave a void, but scattered the very seeds of life across the galaxy. A silent rock from a distant star was already passing us by. In October 2017, the Pan-STARRS telescope in Hawaii caught a faint, fast-moving point of light that did not belong. Its trajectory was the giveaway, a steeply inclined hyperbolic orbit that screamed it was not from here. This was Oumuamua, the first confirmed interstellar visitor, a scout from another solar system. It had been traveling for millions, perhaps billions, of years through the empty galactic void before briefly piercing our neighborhood. As it sped away, data revealed two profound surprises. Its shape was wildly elongated, perhaps 10 times as long as it was wide, a cosmic cigar tumbling through the void. More puzzlingly, it was not moving solely under the sun's gravity. A tiny, persistent push was giving it an extra kick, a non-gravitational acceleration. The most accepted explanation is outgassing, the same process that drives comets. As the sun warmed its surface, hidden ices would have turned to gas, jetting away like an invisible engine. Yet Oumuamua displayed no visible coma, the classic cloud of gas and dust that surrounds a comet. This lack of a tail, combined with its strange shape, ignited a firestorm of speculation. Could it be a light sail, a piece of ancient alien technology coasting through the galaxy? While most astronomers favor a natural origin, perhaps a shard of a Pluto-like world shattered by a distant impact, the mystery remains. Oumuamua was a brief, tantalizing handshake from the galactic community. It proved that our solar system is not an island, but a port in a cosmic sea, constantly visited by driftwood from other shores. Its silent passage announced that the stuff of other worlds is all around us, if only we look fast enough. And we did not have to wait long for a second package from the stars to arrive. The second package from the stars arrived just 2 years later, this time with a familiar face. In August 2019, an amateur astronomer in Crimea named Gennady Borisov spotted a faint, fuzzy visitor with his homemade telescope. This object, designated 2I/Borisov, was immediately recognized as something extraordinary. Its trajectory was even more hyperbolic than Oumuamua's, a perfect arc confirming its origin far beyond our sun's influence. But unlike the cryptic, tailless Oumuamua, Borisov was a textbook comet. As it swung around the sun, it developed a brilliant, streaming tail and a hazy green coma of gas and dust, a classic spectacle that had been witnessed in our own solar system for millennia. This very normalcy was the profound shock. It confirmed that the basic processes of planetary system formation are universal. Other stars have their own Oort clouds, their own reservoirs of icy planetesimals, and their own gravitational interactions that can fling these primordial snowballs into the galactic void. Borisov was a direct, uncontaminated sample from a star system we will never visit. Telescopes around the world swiveled to analyze the light scattered from its coma, performing remote chemistry on a piece of another world. They found it was rich in carbon monoxide, a signature that suggested it formed in a very cold, distant region of its home system, perhaps around a red dwarf star. This was the first time we could directly compare the composition of an extrasolar building block to our own. The sheer frequency of these discoveries, 2 in just 2 years, suggests a staggering truth. The galaxy must be teeming with such wanderers, countless trillions of icy and rocky fragments constantly crisscrossing the vast spaces between stars. Our solar system is not a secluded island, but a participant in a grand, galactic ecosystem of material exchange. This cosmic cross-pollination forces a thrilling question. If rocks and ice can travel so easily between stars, could the same be true for the raw ingredients of life itself? Life clings to existence in Earth's most unforgiving corners. In the crushing pressure of the deep ocean, colonies of tube worms thrive in water heated to boiling by volcanic vents. Microbes flourish in lakes of pure acid and in rocks buried miles beneath our feet, living on nothing but chemical energy in total darkness. These are the extremophiles, and their discovery shattered our narrow definition of a habitable world. Life is not a delicate flame. It is a tenacious force that can take root anywhere it finds a sliver of energy and stability. This resilience gives profound weight to an ancient and cosmic idea, panspermia. The hypothesis suggests that life's raw ingredients, or even dormant microbes themselves, can hitch rides across the solar system and beyond, encased within the protective rock of asteroids and comets. Laboratory experiments have proven that certain hardy bacteria and lichens can indeed survive the vacuum, radiation, and temperature extremes of interplanetary space, especially when sheltered inside a meteorite. This transforms our entire perspective on life's origins. If we one day discover microbial life in the subsurface ocean of Jupiter's moon Europa or in the Martian soil, the stunning truth might be that it is not a second, independent genesis. It could be our distant cousin. Both Earth and that other world could have been seeded by the same biological delivery system, a shower of life-bearing rocks scattered by a cosmic impact billions of years ago. The universe may not be filled with separate sparks of life, but with a single, sprawling family tree whose roots are written in the dust of comets. This vision of life as a cosmic traveler perfectly prepares us for the discovery of worlds that are themselves wanderers, not just between stars, but in the most impossible orbits around them. The dream of a second Earth moved from speculation to a tangible point of light. Kepler 22b was not just another world among thousands. It was the first confirmed exoplanet found orbiting comfortably within its star's habitable zone. This is the Goldilocks region, that magical distance from a star where the temperature is just right for liquid water to potentially pool on a planetary surface. Discovered in 2011 by the relentless Kepler Space Telescope, this world offered a profound answer to a fundamental question: are planets in the sweet spot a cosmic rarity? The data said no. Kepler 22b, circling a star very much like our own Sun, demonstrated that the basic conditions for life as we know it are not a fluke. The planet itself is a super-Earth, with a radius about 2.4 times that of our home world. We do not yet know if it is a rocky giant, a watery globe, or a gassy mini-Neptune, but its discovery was never about the specifics of this one world. It was about the principle. It was the moment the galaxy suddenly felt far more hospitable, a place teeming with real estate that could, in theory, support biology. This single discovery injected immense optimism into the search for life, transforming it from a hopeful quest into a realistic, data-driven pursuit. If a sun-like star could host such a world, then our attention naturally turns to the stars that dominate the galactic population, the dim, red dwarfs that burn for trillions of years, and the strange, ocean-covered worlds we now know orbit them. Our sun feels like a lonely guardian, but some stars build entire families in a fraction of the space. 39 light-years away, a star no larger than the planet Jupiter hosts a miniature solar system of breathtaking complexity. This is the TRAPPIST-1 System, a compact metropolis of 7 rocky worlds, all roughly the size of Earth. Their orbits are so incredibly tight that you could fit the entire system comfortably within the distance from our Sun to its innermost planet, Mercury. If you stood on the surface of one of these worlds, the neighboring planets would loom in the sky like our own Moon, their geological features sometimes visible to the naked eye. The profound surprise was that 3 of these 7 siblings orbit squarely within their star's habitable zone, that temperate band where liquid water could theoretically exist. This arrangement shatters our solar system-centric view of planetary spacing. It presents a unique laboratory for a new science, comparative planetology. Imagine being able to study the atmospheres of 3 different potentially habitable worlds all at once, all orbiting the same faint star. We could directly compare their climates, their chemical compositions, and search for the telltale signs of life on a planetary scale we have never before attempted. This system is a prime target for the next generation of telescopes, a place where the search for biosignatures becomes a multi-world endeavor. It proves that the small, dim red dwarf stars, which make up the vast majority of stars in our galaxy, are not barren wastelands. They can be bustling hubs of rocky real estate, offering countless new opportunities for life to emerge. While this tiny star system dazzles with its planetary density, our own galaxy produced a signal of such incredible density that it defied all natural explanation, arriving in a pattern that felt almost engineered. The universe finally revealed its goldsmith. In 2017, the LIGO detectors felt a new kind of tremor, a gravitational wave signal that was different from all the rest. It was not the final, clean chirp of 2 black holes merging in darkness. This signal lasted for a full 100 seconds, a long, rising siren song of 2 objects spiraling ever closer. The source was a pair of neutron stars, the impossibly dense corpses of long-dead suns, each a city-sized sphere containing more mass than our entire sun. Their collision was not a silent event. For the first time, telescopes across the globe and in space were alerted and swiveled to the same patch of sky. They saw it, a brand new point of light blazing in a distant galaxy, a phenomenon known as a kilonova. This was multi-messenger astronomy in its full glory, a cosmic event where we could both hear the shudder in spacetime and see the brilliant flash of light. The aftermath of that explosion was the true revelation. Spectroscopic analysis revealed the definitive fingerprints of newly forged elements, the heavy stuff of planets and jewelry. This single event created staggering amounts of gold, platinum, and uranium, blasting them out into the cosmos. The kilonova confirmed that these violent stellar collisions are the universe's primary forges for the elements heavier than iron, solving a mystery that had puzzled scientists for generations. The gold in a wedding ring, the platinum in a catalytic converter, the uranium that powers reactors, all were born in the spectacular death dance of 2 neutron stars. Witnessing the violent birth of these cosmic elements makes the discovery of a star from the universe's infancy, a relic that witnessed those first forges, feel like meeting a living ancestor. A star appeared to hold a birth certificate older than creation itself. Designated HD 140283 and nicknamed the Methuselah Star, this ancient sun drifted through our galactic neighborhood while carrying a staggering secret. Initial measurements of its composition and brightness pointed to an age of around 14.5 billion years. This number sent a shockwave through cosmology, for it was nearly a billion years older than the universe's calculated age of 13.8 billion years. The paradox was impossible, a clear sign that a critical piece of our understanding was profoundly wrong. Was the universe older than we thought? Or were our models for how stars live and die fundamentally flawed? The answer forced a painstaking refinement of both stellar physics and our cosmic yardsticks. Astronomers realized the initial estimates had overlooked key details, such as the star's precise oxygen content, which affects its apparent brightness and perceived age. Then, the European Space Agency's Gaia mission provided a stunningly accurate new measurement of the star's distance. With this crucial data point corrected, the pieces of the puzzle finally clicked into place. The Methuselah Star's true age was recalculated to approximately 13.7 billion years, making it a contemporary of the cosmos, a relic from the very first generation of stars. This correction was not a failure, but a triumph of scientific rigor. It demonstrated the incredible precision required to read the universe's deepest history and confirmed that we are indeed surrounded by ancient witnesses, stellar grandparents that formed when the galaxy was in its infancy. This near miss with an impossible age proves the oldest stars are truly the founding elders of the Milky Way. If we can find a star that is almost as old as everything, then what about the very first structures that ever congealed from the primordial darkness? For countless generations, the story of our own solar system's birth was a beautiful theory written in the dust of the past. We had the elegant nebular hypothesis, the idea that a collapsing cloud of gas and dust spun into a disk from which planets coalesced. But it was a story without a photograph, a creation myth based on the forensic evidence of the present. That all changed when our telescopes finally pierced the veils of nearby stellar nurseries. There we saw them, the birth cradles of worlds. These are the protoplanetary disks, vast, flattened platters of gas and dust swirling around infant stars. The surprise was not just seeing them, it was the breathtaking detail they revealed. These were not featureless halos of light. Hubble and other powerful instruments showed disks etched with intricate patterns, dark gaps like freshly plowed cosmic furrows, and bright rings that shimmered like tree rings on a celestial scale. These structures are the gravitational signatures of planets in the act of being born. A clear gap in the dust is likely the wake of a young, growing world, its gravity sweeping its orbit clean like a celestial snowplow. A spiral arm winding through the disk could be the wake of a Jupiter-sized infant, its mass already sculpting the raw material of its future home. This was no longer a simulation, it was a live feed. We were watching the very process that, 4.5 billion years ago, built our own world from stardust and chaos. To witness these planetary nurseries in all their structured glory is to finally have the blueprint, to see the cosmic assembly line in motion. It grounds the wild diversity of exoplanets we have since discovered, showing us the common, violent, and beautiful origin story that every world, no matter how strange its final orbit, must share. The first world we ever watched cross the face of its star was also the first we saw dying in real time. Known as Osiris, the planet HD 209458b offered a new kind of cosmic horror. It was a gas giant orbiting so close to its sun that its year lasted just 3.5 Earth days, a proximity that baked its atmosphere to a furious 20,000 degrees Fahrenheit. Then the Hubble Space Telescope saw something unprecedented. It detected a gargantuan cloud of hydrogen boiling off the planet and streaming into space, a brilliant, comet-like tail that stretched over 200,000 kilometers long. This was not a static world. It was a world actively evaporating, its very atmosphere being blasted away by the relentless stellar wind. The discovery shattered the idea of planets as permanent monuments. They can be dynamic, transient entities, their futures dictated by the violence of their stellar parents. For Osiris, the prognosis is a slow, agonizing demise. Over billions of years, the entire gaseous envelope that makes it a planet could be stripped away, leaving behind a scorched, barren core, the skeleton of a former giant. This ability to witness atmospheric disintegration from light years away opened an entirely new field of study. We are no longer just finding planets, we are performing autopsies on them, learning their life cycles by watching them die. To see a world slowly unmade makes the sudden appearance of a planet in a place where no planet should logically survive feel like a miracle of cosmic defiance. Our own solar system offers a simple choice: either a solid, rocky world under your feet or a giant ball of swirling gas. But the cosmos has no obligation to follow our local zoning laws. 33 light-years away, a world named GJ1214b orbits a dim red star, and its very existence defies our planetary taxonomy. It is a super-Earth, a class of world completely missing from our own solar system. With a mass nearly 7 times that of Earth and a radius over twice as large, it occupies the perplexing middle ground between a rocky planet and a gaseous mini-Neptune. The true surprise is not just that it exists, but that worlds like it are incredibly common throughout the galaxy. They fill a gap in our cosmic inventory we did not even know was empty. The profound mystery of GJ1214b lies beneath its thick, opaque atmosphere. What kind of world is it really? Is it a vast, global ocean, a water world with a steamy, vaporous sky and a deep, high-pressure ice layer at its core? A substance so dense and strange we cannot recreate it on Earth? Or is it a mini Neptune, a world with a small, rocky core utterly smothered by a deep, hot envelope of hydrogen and helium gas? Our telescopes cannot yet tell us for sure, and both possibilities are equally alien to our experience. This single discovery shattered the neat binary of our solar system. We were forced to invent entirely new models of planetary structure to account for these in-between worlds, to understand how a planet can form with so much mass yet not become a gas giant. The sheer prevalence of super-Earths suggests a humbling truth. Our own solar system, with its clean separation between the inner rocky planets and the outer gas giants, might be the galactic oddball. The common architecture for planetary systems may be one rich with these hybrid worlds, planets that are neither truly terrestrial nor truly gaseous, but something entirely their own. This cosmic reshuffling of what is normal makes the next discovery feel almost inevitable. A planet that does not just defy our categories, but actively mocks the very direction of its orbit. A planet decided to orbit the wrong way. In the serene order of our solar system, every planet dutifully follows the sun's counterclockwise spin, a harmonious family tracing out graceful ellipses. So the discovery of a world like WASP-17b was a profound violation of this cosmic choreography. This gas giant, larger than Jupiter, does not merely have an eccentric path. Its entire orbit is tilted so extremely that it circles its star backwards, moving in the opposite direction of the star's own rotation. This is a retrograde orbit, and its existence shattered the foundational model of planetary formation. Planets are born from a single spinning disk of gas and dust encircling a young star. Like riders on a carousel, they should all inherit the same direction of motion. A planet orbiting backwards is like a car suddenly driving in reverse on a freeway, a clear sign of a catastrophic past event. The most likely culprit is a gravitational duel, a violent interaction with another massive planet in the system, or even a close encounter with a passing star. Such an event could have gravitationally slingshotted WASP-17b, flipping its orbital plane and stranding it in its current, rebellious path. This single world proved that the calm arrangements we see today are not always the result of gentle birth. Many systems undergo a period of dynamic chaos in their youth. A gravitational pinball where planets are hurled into star-crossing orbits, ejected into the void, or, as in this case, turned completely upside down. The universe is not always a place of order, but often a record of ancient celestial violence. This evidence of a world knocked from its expected path makes the discovery of a moon actively reshaping its own surface feel like a testament to an inner, vibrant life. Jupiter's moon Io should have been a frozen, silent relic. Instead, Voyager 1's cameras captured a world in the throes of a volcanic inferno. Plumes of sulfur and gas erupted from its mottled surface, rising hundreds of kilometers into the black sky. This was not the gentle, cold moon everyone expected. It was a celestial pressure cooker, its yellow and orange surface constantly remade by volcanic fury. Io is, by a staggering margin, the most volcanically active body in our entire solar system. The source of this fire is not a molten core left over from its formation, but a gravitational tug of war. As Io orbits Jupiter, the immense gravity of the giant planet pulls and squeezes the moon. But its path is not a perfect circle, it is an ellipse, and it is also being gravitationally yanked by its massive sibling moons, Europa and Ganymede. This constant, rhythmic stretching and compressing generates immense friction deep within Iowa's rocky body, heating it to a molten state in a process called tidal heating. The discovery was a complete paradigm shift. Geological activity was no longer a privilege reserved for worlds close to the Sun. Here, in the deep freeze of the outer solar system, a moon was being cooked from the inside out by gravitational forces. This single observation rewrote the rules of planetary science. It forced astronomers to look at every icy moon in a new light. If tidal forces could turn Io into a volcanic hellscape, could that same gentle, internal warming create a very different environment on a moon like Europa, a world encased in a global shell of ice? The fiery chaos of Io became the key that unlocked the possibility of hidden, life-giving oceans elsewhere. Io's volcanic fire pointed directly to a world of hidden water. While that moon was being torn apart by friction, its neighbor Europa was receiving a gentler, more life-giving version of the same treatment. Galileo's stunning images of Europa revealed a world unlike any other, a cracked and frozen eggshell of ice, crisscrossed with long, dark streaks and jumbled terrain. It looked less like a dead moon and more like the sea ice that forms over Earth's polar oceans. The profound surprise was not just the surface, but what the surface implied. Data from the spacecraft's magnetometer provided the crucial clue. As Europa passed through Jupiter's powerful magnetic field, it generated a secondary, opposing field. The only plausible explanation for this magnetic signature was a global layer of electrically conductive fluid. And the only fluid that fit the bill, buried beneath the ice, was a vast, salty ocean. The calculations that followed were staggering. This subsurface sea, hidden from view, contains more than twice the volume of all the water in Earth's oceans combined. Think of every sea, every lake, every drop of water on our entire planet, then double it, and you have the scale of this single alien ocean. This discovery shattered the classic idea of the habitable zone, that narrow orbital band where a planet is just the right temperature for liquid water on its surface. Europa lies far outside that zone, in the deep freeze of the outer solar system. Its ocean persists because of the relentless tidal kneading from Jupiter's gravity, the same process that heats Io, but here it creates a stable, warm, dark sea. This introduced the concept of a subsurface habitable zone, a realm where life could thrive not on a sun-drenched surface, but in the abyssal dark, powered by geological energy and chemical reactions. Europa instantly became one of the most promising places to search for life beyond Earth, a water world waiting with its secrets locked under ice. The quest then became how to taste that hidden sea, a challenge that found a stunning answer not at Jupiter, but at a tiny, icy moon orbiting Saturn. A tiny, frozen moon was caught spraying its hidden ocean into space. The Cassini spacecraft, orbiting Saturn, witnessed a spectacle that defied belief. From the south pole of the small, bright moon Enceladus, immense geysers erupted, shooting towering plumes of water vapor and tiny ice grains hundreds of kilometers into the void. This was not a dead ball of ice, it was an active world, and its cryovolcanoes were screaming for attention. Unlike the molten rock of Earth's volcanoes, these are cold volcanoes or cryovolcanoes. Here, the erupting material is liquid water that acts as lava, bursting through cracks in the moon's icy shell and instantly freezing into a brilliant plume of snow. Cassini did not just watch from a distance, it took a daring plunge, flying directly through these cosmic fountains. The analysis of that material was the true shock. The plumes were not just pure water. They were a complex cocktail rich in sodium salts and, most excitingly, simple organic molecules. These are the carbon-based building blocks that are essential for life as we know it. Enceladus, in a single stunning gesture, had provided a free sample of its subsurface ocean, a sample we did not even have to drill for. This transformed the search for life from a distant dream into a tangible mission. We now know this small moon possesses a global saltwater ocean, heated by the same tidal forces that churn Io and Europa, and it is actively delivering the potential ingredients of its hidden biology right to our spacecraft. The sheer accessibility of this ocean, spewing its contents into space for anyone to analyze, stands in stark contrast to the opaque, crushing atmospheres of distant gas giants, where the secrets are locked away under impenetrable layers of cloud. Venus presents itself as a planetary twin, a world of similar size and composition to our own. Yet its atmosphere is a study in cosmic contradiction. The planet itself rotates with an agonizing slowness, a single Venusian day stretching longer than its entire year. But high above this sluggish surface, the upper atmosphere is caught in a hurricane of impossible speed. A perpetual, supersonic wind screams around the entire planet, reaching velocities over 200 miles per hour. This is superrotation, a phenomenon where the atmosphere races around the planet 60 times faster than the solid globe beneath it rotates. The entire gaseous envelope completes a full circuit every 4 Earth days, a whirling dervish shrouding a near-stationary core. What force could possibly drive such a relentless, planet-wide gale? The thick, choking air of Venus is almost pure carbon dioxide, a heavy gas that should cling and drag, not fly. Scientists believe the answer lies in a complex transfer of energy, where heat from the sun-drenched dayside creates massive pressure differences, and the planet's slow spin offers little resistance to build up these incredible winds. It is a global weather engine of terrifying efficiency, a mystery that reminds us that similarity in size does not mean similarity in soul. The atmosphere of Venus is an alien entity, a fluid dynamic puzzle operating on a scale we are only beginning to comprehend. This bizarre, high-speed shroud makes the revelations about the planet's hidden surface feel like a descent into an entirely different world. Venus hides its scars beneath a smothering shroud. For decades, its surface was the solar system's greatest blind spot, a landscape of pure speculation. Then the Magellan spacecraft arrived, piercing the acidic clouds with its radar eye. The map it sent back was not what anyone expected. Instead of a cratered relic, a fossil world bearing the ancient marks of a violent past, Venus presented a face that was smooth, fresh, and unnervingly young. The entire global surface appeared to be only 300 to 600 million years old. This was a planetary facelift of unimaginable scale. The near-total absence of impact craters told a story of erasure. Every other rocky body in the inner solar system, from Mercury to Mars to our own moon, is a pockmarked museum of cosmic collisions. Venus alone had wiped its slate clean. The leading explanation is as terrifying as it is grand, a process of episodic, catastrophic volcanism. Unlike Earth, where plate tectonics constantly but gently recycles the crust in a slow, global conveyor belt, Venus seems to stew in its own internal heat for hundreds of millions of years. Pressure builds, temperatures rise until the planet can no longer contain its fury. The entire crust then fractures and melts in a single, planet-spanning paroxysm, a volcanic outburst that drowns the entire world in a fresh layer of lava, burying every mountain, every valley, every trace of its previous history under a new global skin. This reveals a profound truth about terrestrial planets. They do not all age the same way. Our Earth's steady, plate tectonic heartbeat is not the only rhythm. Venus follows a cycle of long, stifling calm, punctuated by brief, apocalyptic renewal. A geological personality forged in its hellish, runaway greenhouse climate. The discovery that a world can literally repave itself from the inside out makes the existence of a canyon so vast it defies earthly logic feel like the next inevitable shock. The fictional canals of Mars were a mere fantasy, but the planet offered a real chasm that eclipses any earthly imagination. Valles Marineris is not a canyon, it is a continental scale wound, a gash in the Martian crust so immense it would span the entire width of the United States. At over 4,000 kilometers long, 200 kilometers wide, and 7 kilometers deep, it makes our own Grand Canyon look like a scratch on a pebble. You could drop Mount Everest into its deepest trenches, and the peak would still not reach the rim. This was not carved by a single, patient river. Its origins are a testament to planetary trauma. As the colossal Tharsis volcanic bulge swelled on the other side of Mars, the planet's crust stretched and tore open, creating a gigantic crack that became the canyon's foundation. Later, catastrophic floods of water likely surged through this weakness, and countless landslides widened the abyss, sculpting its chaotic, layered walls. This gargantuan scar revealed that Mars was once a world of titanic geological violence, with an active interior and a past potentially warm and wet enough for water to flow freely. It is a fossilized echo of a more dynamic planet. That such a monumental feature exists makes the hunt for smaller, more recent clues about Martian water feel like searching for footprints after an earthquake has passed. Those dark, streaking fingers on the Martian cliffs were a siren song of liquid water. From high above, orbiters watched as these features, called recurring slope lineae, would materialize on sun-facing slopes during the warmest months. They would slowly extend downhill, sometimes for hundreds of meters, as if something were wetting the soil and making it flow. The initial evidence was compelling, pointing toward a briny, liquid water solution. Salt lowers the freezing point of water, allowing it to remain liquid in the thin, frigid Martian air. And this seemed to be the simplest explanation for such dynamic, seasonal behavior. The implication was staggering. It meant that liquid water, the one non-negotiable ingredient for life as we know it, might not be locked away in a buried ocean or a polar cap. It could be seeping out onto the surface of Mars right now, in our time. This was not a story about a wet Mars billions of years ago. This was a headline from the present. The excitement, however, soon met with a wave of rigorous skepticism. When scientists looked more closely, they found that many of these streaks did not show the specific mineral signatures you would expect from evaporating water. Alternative explanations emerged, suggesting these could be dry, granular flows. Imagine fine, dark sand or dust grains, destabilized by the sun's warmth, cascading down a steep dune in a silent avalanche. The debate is a perfect example of science in action, a tug-of-war between two compelling but very different realities. One paints a picture of a world where life could, in theory, still find a damp foothold. The other suggests a more arid, but still active, geological present where the planet is constantly reshaping its own face. Regardless of the final answer, the true surprise of the recurring slope lineae is the undeniable activity they reveal. Mars is not a dead world.